3.1. Solve linear systems by graphing. Vocabulary. System of two linear equations. Any two linear equations that can be written in the form ax plus by equals c, and dx plus ey equals f. Just any two normal linear equations. The solution of a system where the lines cross or the ordered pair that makes both true. Consistent. Consistent has solutions. It can also be consistent and independent, which means it has only one solution, or it could be consistent and dependent, which means it has many solutions. So, if it has one solution, the two lines cross at some point. If it has many solutions, the two lines are graphed on top of each other. They're really one line. The other thing it could be is inconsistent. Inconsistent has no solutions because the lines are parallel. Okay, example 1. Solve a system graphically. Okay, on equation 1. One of the first things to look for if you're going to solve graphically is to look that if you can make this equation any easier. And I can by dividing everything by 2 on equation 1. So my new equation 1 would be 2x plus y equals 2. Now I'm going to go ahead and graph that. Let me go ahead and put it into slope-intercept form. So y equals negative 2x plus 2, which means I have a y-intercept of 2, and I'm going to go down 2 and over 1, down 2, over 1, down 2, and over 1. Now you'll notice on this that I put in quite a few points. And the reason why I put in quite a few points is sometimes it's very hard to see where these cross. So the more points you put in, the better your answer will be. All right, on equation 2, let's see. Let's go ahead and change that over to slope-intercept form. So I have negative 3y equals negative 2x plus 10. Divide by negative 3. Okay. So I have y equals 2/3 because negative divided by negative is a positive, x plus, minus 10 over 3. Not a very good thing to graph. Let's just go ahead and do an xy box. So if I put in a 0 for x, what am I going to get out for y? Negative 10/3, and that's negative 3 1/3. So that would be about right here. Now if I put in a negative 1 for x, that would be negative 2/3 minus 10/3. So So that'd be negative 12 thirds, which would be negative 4. So negative 1 is 1, 2, 3, 4. Now, if I put in a positive 1, how about positive 2? So put in a positive 2, that would be 4 thirds minus 10 thirds, would be a negative 6 thirds, which would be negative 2. So if I put in positive 2, I get a negative 2 out. And do you see that they would cross right there? So the solution is the point where they cross, which would be 2 and negative 2. Now, to check this, I need to put them both into, or put the x and y into both equations. So back in equation 1, 4 times the x, which is 2, plus 2 times the y, which is negative 2, does it equal 4? 8 minus 4, yes, it does equal 4. 4 equals 4. And equation 2, 2 times 2 minus 3 times negative 2, 4 plus 6, yes, it does equal 10. Check. So, what you need to do on these, if you're going to graph them yourself, is to make sure to put in quite a few points so you can cross the lines and get the right point. Okay, on this checkpoint, go ahead and try this. Do you notice that on this second equation, it would be, you can divide everything by maybe a negative 3, and that would make it a little bit better to work with. So that's what I would do first. Okay. And then it does cross at a nice point, so get the closest corner to wherever your graph shows. And then start the video again when you're through. Okay, so here are the 3 ways that we could have 2 lines. 2 lines could have exactly one solution. That would mean that they would cross at a point. And we call this consistent. Consistent means it has a solution. And independent. Independent means there's only one solution. Now, infinitely many solutions would mean that the 2 lines are graphed on top of each other. On top of each other. This means that they're consistent and then they're dependent. No solution, the lines are parallel and they are inconsistent. If you remember your prefixes, in means not a lot of times. So, example 2, solve a system with many solutions. We have equation 1 and equation 2. So, if I was just looking at this, what would I probably tell you to do to equation 2? I would say, I bet all those could be divided by 2. So, let's go ahead and divide them by 2. 2x minus y equals negative 4. Okay, if I flip all the signs on here, do you notice that this is just equation 1 over again? So that would mean that these are both the same line. and it would have infinitely many solutions. Therefore, this system is, what were those root words for it? Consistent and dependent. If I wanted to graph these, I could put in a 0 for y up here, and x would be -2. So -2 and 0. And then if I put in a 0 for x, y would be 4. So here are the lines. Same line on top of each other. Okay, solve a system with no solutions. All right, on equation 1, do you see that we can divide it by 2? So let's do that. Negative x plus 2y equals 4. And divide the bottom by 2, so negative x plus 2y equals -2. So if I put in a 0 for x on the first equation, I get 2 out for y. If I put in a 0 for y, I get a -4 out for x. And then that would be the first line. On the second line, if I put in a 0 for y, I get 2 out for x. And if I put in a 0 for x, I get -1 out for y. And here is this line. If I could draw a little bit better, you would see that they were parallel. Another good way to see that is, let's go ahead and change these to slope-intercept form. So here's my first equation again. Go ahead and move my x over. So 2y equals x plus 4. Divide by 2. Y equals 1/2 x plus 2. Now for my second equation, negative x plus 2y equals -2. 2y equals x minus 2. Divide by 2 again. So y equals 1/2 x minus 1. Notice that these two lines have the same slope but different y-intercepts, which is our definition of parallel. Okay, on this checkpoint, solve these systems. Classify the system as consistent and independent, which means they have one solution. Consistent and dependent, which means they have many solutions. Or inconsistent, which means that they are parallel.